Welcome. The subject we're going to deal with today is what is a grand solar minimum? A lot of people have been talking about it recently, saying that we're either in one or we're about to go into one, and there's going to be all sorts of dire consequences if we do end up in a grand solar minimum. But there's no real definition for a grand solar minimum, and everybody seems to have a different one. So let's try and sort that out. What really should be the definition of a grand solar minimum? Are there things we can actually agree about? A lot of people point to the Maunder minimum as an example of a grand solar minimum, and I think most people would agree with that because we had a 70-year period without very many sunspots, or in fact much of the time no sunspots at all. The greater question is the Dalton minimum a grand solar minimum, as some claim, and are we in one now, as some claim? And I think the answer to both of those is no, and the reason why this will become clear as we go along. Wikipedia, of course, has a definition of a grand solar minimum, and it's one that several people have used. A grand solar minimum occurs when several solar cycles exhibit lesser than average activity for decades or centuries. The problem with this is exceedingly vague. How many is several? And what's lesser than average? What is average? There's a scientific definition of average, but is that what they mean? And if you're doing averaging, what data do you use? The data is different from place to place. And then what is a significant departure from average? All these questions must be answered if you're going to have a precise scientific definition of a grand solar minimum. Several is vague. Different dictionaries define it in different ways, either 2 or more or 3 or more, and fewer than many. They don't define what many is either. So we lack a scientifically precise definition that we can use to define a grand solar minimum. Well, if we need a more scientifically precise definition, well, let's try and create one. What's the starting point? A grand solar minimum is defined as a significant period of time where the sunspot number is significantly below the average. Of course, we need to define significant in each one of these cases. And then again, you have to define what average means. And both of those are a lot more tricky than you might think. Significance is defined generally in terms of the bell curve and standard deviations. If you have a measurement, but that measurement varies from time to time or from place to place, you have a range of values. If you take an average of those, that would be represented by the 0 here, then the bell curve is the number of points away from that average. And the further away you go from that average, the more unlikely that value is to be real. Standard deviations is measured in sigmas, which is a measure of the noisiness of the data. If you go plus or minus 1 sigma, you have 68% of the data encompassed between those 2 points. 2 sigma, you add another 27%. 3 sigma, you add another 4.5%. If you've got a 1 sigma result, you have a 2-to-1 chance of being correct. If you have a 2 sigma result, you have a 19-to-1 chance of being correct. And if you have a 3 sigma result, you have a 332-to-1 chance of being correct. Now, most scientists would like to have 3 sigma, but generally 2 sigma is the standard. So let's assume for the moment that we're going to take a standard 2 sigma variation from the average to mean a significant result. The problem with an average is that it changes every time you get a new piece of data. So should we get a very large cycle, the average will go up. If we get a very low cycle, the average will go down. So you can't really deal with a changing average in the sort of definition that we're looking for. The average for the 24 cycles that we have data for at the moment is 116. Now that's using the NOAA definition of sunspot number. The SIDC's definition of sunspot number puts that average at 180. They just use different criteria. But of course, if we took it over the full 400 years, even assuming that the red data is sufficiently accurate to add in, the average would be 100. And so that's a significant difference between the average for these various cycles. So you have to be very careful. And also the standard deviation from this would be much, much larger. it would render these data such that there was no grand solar minima or grand solar maxima. Well, let's take a look at the variability of the solar cycle. Now here I'm using the smooth sunspot number from the SIDC shown here on the right in this table. The maxima for the last 24 cycles varies between 81 and 285. The average, therefore, from using the SIDC data is 179. The standard deviation on that number is 58 because, as you can see from the smooth maxima, there's a lot of variability. So if we define a significant change as being 2 sigma, anything below 63 would be considered a significantly low point. Anything above 295 would be considered a significant high point. Well, how does that affect our original plot of all the previous solar cycles? Let me blank out the areas that would be considered insignificant changes based on that standard deviation. So I've blanked that all out, and really the only points that are below that threshold are the Maunder minimum for a period of about something like 70 years and 1 cycle in 1800. There are some points where the maximum exceed, but they're not for extended periods. In fact, none of these are extended periods except for the Maunder minimum. So I think we're very safe with this definition, saying the Maunder minimum is something special and therefore could be called a grand solar minimum. So we can pull all this together and try to define a grand solar minimum as a period not less than 3 consecutive solar cycles where the smooth sunspot number, based on the SIDC numbers, at maximum does not exceed 50. And similarly for the grand solar maximum, we could say a period of not less than 3 consecutive solar cycles where the smooth sunspot number, based again on the SIDC, at maximum exceeds 300. So let's draw some conclusions from all of this. We do need a clear scientific definition of a grand solar minimum and maximum. And I've provided a template for one in the preceding slides. It has to be quantitative and based on physical measurements. It can't be just subjective. Based on that, we've only had one grand solar minimum, the Maunder minimum, and that the Dalton minimum and the current minimum are not considered grand solar minima. We have not yet observed a grand solar maximum. So thank you for watching this video. If you liked it, please pass it on to others who would be of interest to see it. So until next time, stay safe and goodbye.